In this lesson, we are going to learn about how do you solve polynomials using the long division method, okay? So take a look at this problem. We have that -1 is one of the zeros of a polynomial, which is a cubic polynomial, right? And then we need to find all the zeros of this given polynomial, okay? So to begin with, let me write my polynomial here. It is x cubed plus 2x squared minus 11x minus 12. Now, since this is a cubic polynomial, because we have the highest power here as the cube, right? We can say that this polynomial is equal to the product of three zeros, right? This is what we have learned in our recent tutorials. And let's say those three zeros are alpha, beta, and gamma, right? Now, we know that -1 is one of those zeros. That means I can simply take one of them and replace that with -1. So the moment I do that, this value will become x plus 1 because negative in front of alpha will cancel out with the -1 of the first zero, right? So this becomes x plus 1. And the remaining two factors will remain as it is. Now, as I take a look at that, I see that there are two sides of this expression, the left and the right, correct? The right hand side contains three factors. What if I simply divide both sides with this factor x plus 1? Right? This expression or this equation will remain balanced because we are dividing both sides with the same factor, correct? But what this will do is that on the right hand side, this will cancel out. And what remains is only two factors. That means this will reduce down to a quadratic form, right? But the problem remains is that I still need to solve the left hand side because there is a cubic polynomial being divided with a binomial. So let's solve this division problem first, and that will help us go to the second step of this problem. So let me make some room here and I will solve this division problem a little bit below. So I have x cubed plus 2x squared minus 11x minus 12, and this is being divided with x plus 1. Now regarding polynomial division, we have learned that whatever is in the divisor term, we need to multiply that with something so that we get at least the first term of the dividend equal to that product, right? So if I simply take x plus 1 and multiply that with x squared, it will give me x cubed plus x squared, right? We are applying a distributive law here. And that is exactly what I have here in the dividend, right? So that means my quotient here will be x squared. I'll multiply this quotient with this divisor, and I can write down my new product here as x cubed plus x squared. Now you will subtract this value just like what we do in the long division, and this will of course cancel out, and 2x squared minus x squared will be x squared, and then I will simply download this entire, the remainder of this expression which is inside the dividend, it will go right here, correct? Just like what we do the standard long division of numbers. So this is my new value here, new dividend, correct? Now I'm looking for another term that I can multiply with this divisor, which is x plus 1, so that the result of that multiplier with this divisor gives me x squared, the first term of my new dividend. And that will be simply what? That will be just x, right? When you do that, you will get x squared plus x. So let's do that and write our second quotient as plus x, and then I get my product here, x squared plus x. Once again, you will subtract. These two will cancel out, and what you get here as a result is -12x, and then this value will come here as it is, right? It will be -12. All right, so if I take x plus 1, which is at the third step, and multiply that with -12, what you get is -12x, -12, right? So I will write my quotient here, -12, because this is what is being used as a multiplier. And then this quotient, -12, will get multiplied with x plus 1. And then I can write my third step here, -12x, -12. So once again, as usual, I will subtract this value from the dividend. So I will do that. And what remains down below is 0 because everything is equal and it will cancel out. Now this means what? This means that you have your divisor, which is x plus 1. You had your original expression, which is x cubed, the original polynomial that we had. When you divided this polynomial with this divisor x plus 1, what you received as a result is this value, the quotient, and the remainder, of course, that was 0, right? That is the ideal state what we want, to have the remainder 0. Now let me get rid of all of these extra multipliers and multiplications so that we can make room for more calculations here. So let me go back up and put that result here in our original expression that we had. So what you have really accomplished is so far that this division that we wanted to carry out, this gives me a polynomial which is x squared plus x minus 12. And that is of course equal to these two factors, the product of these two factors, x minus beta times x minus gamma, right? Now, isn't it much easier to solve this quadratic as opposed to solving this cubic polynomial all at once, right? And that means we are at our step number 2, where we are going to solve this quadratic, okay? So let me create this solution step here. It is x squared plus x minus 12. At this stage, I'm simply looking out that how can I divide this middle term in this quadratic into two parts such that the sum of those two parts is equal to plus x and the product of those two parts is equal to negative 12x squared, which means I'm multiplying this value, the constant part, with the very first term here. That means I'm simply dividing this middle term into two parts, 4x and negative 3x. When you sum them up, what you get is x. When you multiply them together, what you get is negative 12x squared. That means I can write 4x plus negative 3x instead of writing just x, right? So let's do that. Let's erase these extra values here and write the new values of this equation, the x squared plus 4x minus 3x minus 12. Now let's factor the common parts out of this division, the two subgroups that we are making. And the first part, I can take x out. What remains inside the parenthesis is x plus 4. And in the second part, I can take negative 3 out. And what remains inside the parenthesis is x plus 4. Once again, we are going to apply the reverse distributive principle. And I can write that if I simply factor out this x plus 4 from these two subgroups, then what remains inside the parenthesis is x from the first subgroup and negative 3 from the second subgroup, right? That if you simply equate this equal to x plus 4 times x minus 3. I'm simply taking this result and bringing it back here. That means x minus beta is equal to x plus 4 and x minus gamma is equal to x minus 3. And that gives you what? That gives me this final result, that beta will be equal to negative 4. Right? Because it's only when you have negative 4 and you substitute that value negative 4, the negative in front of beta will cancel out with this negative and you get x plus 4, right? And then gamma is of course 3 because these two forms are identical. X minus 3 is equal to x minus gamma, which means gamma is equal to 3. And you already had your very first given 0, that alpha is equal to negative 1. So you have your final result here, that alpha, beta, gamma, the three zeros of this polynomial. So in summary, the key learning you need to take away from this lesson is that you have this polynomial that needs to be broken down into its individual zeros, right? So first you divided that with another polynomial. That was your step number 1, right? As you carried out step number 1, you obtained a quadratic polynomial now, which was slightly easier for you to solve. So then you took to your second step, in which you solve this quadratic as you have seen here. This was your step number 2, solving the quadratic. That gave you your final result, that you obtained the last two factors of this polynomial, and hence you arrived at this solution that you accomplished. So with that, we take a pause here, and this was our objective, that how can we utilize the long division method in solving polynomials.